hold on to them for now. Okay, so this is kind of what should have happened with your WikiSticks. So you should have taken one that was the length of one radius and put it along the edge, and it gave you this angle right here, which in degrees, we didn't have our protractors, but in degrees that would be about 57 degrees. Some of you guessed a little differently. It's fine. It doesn't matter. But in radians, that is 1 radian. So everybody's wiki, I just cut them randomly. So everybody's groups WikiSticks were different, but that angle ended up looking the same. That angle for everybody, if you did it right, was about 57 degrees or 1 radian. So 1 radian is formed when you take the radius of the circle and put it along the circumference of the circle, the edge of the circle. It forms 1 radian. All right, and then you did that again. And over here, this should be 2 radians. Right? And this one right here should be 3 radians. And half of a rotation is actually 3.14 radians. What do you think that is? Pi. And so half of a circle is going to be pi. All right, this one right here was 4 radians. 5. This was 6. This one is 6.28 about. So what do you think that is? 6.28. 2 pi. Yep. Right? So no matter how big your circle is, half of a rotation is going to be pi radians, and a full rotation is going to be 2 pi radians, no matter what. Right? If you wanted to figure out the length of the arc, all you had to do is measure one of your WikiSticks because they were all the same length. They all should have been the length of your radius. So that was number 6. You just use your ruler and measure it. Number 7, how many WikiStick arc lengths did you use before reaching point B? That should have been 3. So it should be just over 3, and this should have been just over 6. Now, if something went wrong with your radius, your circle might have been a little off. It's okay. But the main idea I wanted you to get from this is what a radian actually is. And 1 radian is the angle that's formed by taking a radius and putting it on the edge of the circle. That's 1 radian. Okay, so on the back, we're going to fill in some notes. All right, so angles on the circle are measured from the positive x-axis, and they're measured counterclockwise. And you can measure them either in degrees or radians. All right, so for example, before today, all of our angles were inside of a triangle. Well, angles don't have to be inside of a triangle. You can have angles on the coordinate plane. And so what you do is from the positive x-axis, you're going to rotate a certain amount, and that forms an angle.
What's that word?
Counterclockwise. In the opposite direction that a clock moves. That's how your angles are going to be rotated. If they are rotated in that direction, they're considered to be positive angles, and the negative angles are measured in the clockwise rotation. So a negative angle would go, oh my goodness, would go this direction. Right. So a radian is the measure of an angle whose arc length is 1 radius.
You know, I've always wanted to know how to do this.
Oh, good. You learn about radians, but nobody ever really showed you what it means, I'm pretty sure. But maybe they did. So to change degrees to radians, which is the only thing you really had to do in Algebra 2 with trigonometry, I think, was change radians to degrees and degrees to radians. So if you want to go degrees to radians, you multiply by pi over 180 degrees. Because pi radians and 180 degrees are the exact same angle, they're just in a different unit of measure. So that's like multiplying by 1. And then to go the other way from radians to degrees, you multiply by 180 degrees over pi. And something you probably didn't learn in Algebra 2 is that if you want the radian measure, you can take the arc length and divide it by the radius. Okay, so what we have over here is a circle that has some special angles that are marked off. And so eventually, like next week probably, maybe this week, we'll start talking about the unit circle, where it's a circle with these special angles that has a radius of 1. And we'll talk about it a lot. So we're just going to get started today with the angles. And so straight to the right is going to be 0 degrees. That's where all of these angles start. That's 0 degrees. 0 degrees is also 0 radians, so that's easy. All right. And then what about straight up? What is that in degrees? 90 degrees. What about straight to the left? 180 degrees. And then down? 270 degrees. And then all the way around. Good job. All right, we're going to go back and we're going to also put what those angles are in radians. And so we already talked about half of a revolution was 3.14 radians or pi radians. So 180 degrees and pi radians are the exact same angle, just a different form. What about 90 degrees? What do you think that would be in radians? Half pi, good. Pi over 2. My microphone goes up. All right, what about 270? Pi and a half or 3/2 pi. Good job. All right, now not everybody, a few people wanted 1 radian to be 45 degrees. It wasn't. It's closer to 60, but that's okay. But let's just talk about that 45-degree angle for a minute. So everybody, I think, like you can picture a 45-degree angle in your mind. So halfway between 90 degrees and from 0 to 90 is going to be 45 degrees. So what is that going to be in radians? Yeah, halfway to half a pi. A quarter pi. So half of a half is a quarter. I really need you guys to know that. If you ever want to cook, you need to know that. A half of a half is a quarter. Okay, so let's look at quadrant 2. This is the 45-degree angle in quadrant 2, but it's not going to be 45, right? It's going to be 90 plus 45, which is 135. All right, and it is halfway between pi over 2 and pi.
No, 345 is 135. Think like you're working out.
3/4 pi, yes. I think that's what you said. I'm going to make the color right. All right, and then the 45-degree angle in quadrant 3 is going to be this one. Okay, it's going to be 180 plus another 45 degrees.
25 right here.
Got the wrong color again. All right, and I'm just going to tell you that it's going to be 5 pi over 4. So let's look at those pi over 4 angles. Do you see any kind of pattern?
Fourths.
They're fourths. What about the tops?
Halves.
It was a 1, then it was a 3, and then it was a 5. What do you think the next one's going to be? A 7. And that is going to be 315 degrees right there.
315.
Mm-hmm. All right, so 45-degree angles are special angles that you use a lot. What are some other special angles that maybe would match up with this one? What do you think? It's a little bit bigger, 25.
35.
30. So 30, 60, and 45 degrees are all special angles. And maybe you guys just haven't been exposed to this. It's fine. But that angle right here is a 30-degree angle. And so every time I rotate that much, I'm rotating 30 degrees. So if I rotate that much again, it takes me here. So what's that going to be? 60. All right.
15 for real.
We're not using 15 any. All right, I rotate 30 degrees again, it takes me to 90. I rotate it again, and what does it take me to? 120. All right, I rotate it again, it takes me to 150. And then 180 we already have, and then 210, and then 240, 270 we have, 300, 330. All right, those are the special angles in degrees. Now we need to get them in radians. So we have options. We can take 30 degrees and we can multiply it by pi over 180 if you wanted to. Or I can look and see there's 6 of these little equal spaces from 0 to 180 or 0 to pi. So each one of those rotations is 1/6 pi or pi over 6. All right, so then when I get to 60 degrees, I'm adding another 1/6, which is 2/6. What does that reduce to? 2/6. Yes, so pi over 3 at 60 degrees. All right, if I add it again, I'm going to get, so that's 2, and then 3/6 is 1/2, and then 4/6 is 2/3, or 2 pi over 3. And then 5/6 is 5/6 pi. 6/6 I already have is 1 pi. And then 7/6. 8/6 is 4 pi over 3. 9/6 is 3 pi over 2. 10 is 5 pi over 3. And 11/6 doesn't reduce, so 11 pi over 6. All right, so double check that you got all those filled in. I know it's really tedious. We're going to use this circle so much. And the more you use it, the more you're going to see a pattern. What was your question? I thought someone said something. No. 11 pi over 6, yes. Now my other pre-calculus class, we didn't use this year any degrees. So they actually had it a little bit easier than y'all because you are learning this with degrees and with radians. Okay, so let's look at number 1. We want to find each angle in radians. So that's easy. You're just going to go to your circle, look at 30 degrees. What is 30 degrees in radians? Just pi over 6. So you guys do B, C, and D on that on your own, just looking at the circle and given the radian measure for each degree angle. So on number 2, we are doing the other thing. We have it in radians, we're changing it to degrees. It's going to be a little more difficult because there are no pi over 7s on our circle. We just have, our denominators are only 6, 4, 3, and 2. There's no other denominator. So we're going to use this guy right here to go from radians to degrees. So we're just going to take pi over 7 and we're going to multiply it by 180 degrees over pi. So what's going to happen to the pi's? They're going to cancel. And in your calculator, you would just do 180 divided by 7, and you get approximately 25.71 degrees. All right. And then 3 is asking us just to find things in common on the unit circle. So A asks, what do you notice about the radian measure of all the angles that are multiples of 60 degrees? So my multiples of 60 degrees are these. What do you notice about their radian measures? 3's in the denominator. All right. What about all of the angles that are multiples of 30 but not multiples of 60? So we're talking about these guys. What do you notice about their radian measures? All the denominators are 6. All right, 6. Or sorry, I don't know why I said that. C, which angles are multiples of pi over 6 and pi over 4? Now, right now, I think it's hard for you to think in terms of radians, but it's easier to think in terms of degrees. So we want to know all of the angles on this unit circle that are multiples of 30 degrees and 45 degrees. All right, so multiples of 30 and 45 degrees. 90. What else? 180. Yes, and 360. So those are, let's write them in radians since they asked the question in radians. So pi over 2, pi, 3 pi over 2, and 2 pi. Those are called the quadrant angles. So the ones are on the vertical axis or horizontal axis are called the quadrant angles. Oh, we're doing great on time. I was confused. We have extra time today. I forgot. We have a whole hour. Yeah. Okay. And so number 4, an ant is walking around the perimeter of a circular wreath. Let me show you how good I can draw a circle. Watch this. Isn't that beautiful? All right. And so the radius is 8 inches. If the ant walked 21 inches, that's a lot. Let's say all of this is 21 inches. How many radians is the central angle? That's supposed to be theta. Doesn't look like it. That intercepts her path. So this is a formula that up until now you might not have ever used, but it's this guy right here. The radian measure is going to be equal to the arc length divided by the radius. Yes. So 2.625.